The area under a curve. The mathematical magic begins. Oh, this is great stuff. You set your cruise control to 60 miles an hour and you drove east at that exact speed for the first 3 hours of a trip. So let's just ignore the time that it took you to accelerate. That's just negligible. Negligible means just not worth counting. So let's just assume that magically you defy the laws of physics and boom, you're going 60 and you drive exactly east. I'm going east because I kind of want to prove a point about how your direction implies distance, velocity, that sort of thing. We'll deal with that later. But in the meantime, how far did you drive in the first 3 hours? Okay, really, please don't make this harder than it is. How far did I drive in the first 3 hours? We'll pick a color. Sounds good, we'll do that. I hope you picked what I just picked. I drove 180 miles, which is not rocket science. It is the rate at which I drove. I'm writing a little bit too much here, but I'm proving a point. It's 60 miles an hour for 3 hours. And I end up with, watch the units here. This is cool. Hours cancel, 180 miles. Okay, not rocket science, but just good to know this idea is going to continue. The units are important. Let v of t represent your velocity for the trip. What is the velocity for 0 to 3? Okay, just write a function, the velocity. We've dealt with velocity before, and the velocity, that's why I said east, again, because I want it to be positive. If I had been driving west, just from our point of view, looking at a map in the standard way, we might say, oh, it's negative. I didn't want to play that game, so that's why I said east. Anyway, off topic. What is my velocity? It's 60. Well, is it 60 times t? No, it's 60. My velocity is 60. I'm always driving 60. That's it. So graph the velocity. The y-axis is on a scale of 10, which means that up here we have 60. And down here we are not on a scale of 10, so this is going to be hours. This is hours, and this is miles per hour. And you're about to have an amazing discovery. I'll graph it in red. When I graph the line 60, that's what we get. All right, fun. Well, wow. Nothing too tragic so far. I think we got this. And then what does the y-axis represent? I'm not even going to answer that because we just did that. That is the velocity. What does the x-axis represent? It's hours. And then what is the area bounded by the graph of the function and the x-axis? Okay, let's read that carefully. What's the area that's bounded or bound by the graph of the function, this horizontal red line at y equals 60, and the y-axis, the x-axis? I want to know what's the area of that rectangle that I just did a terrible job shading. What is the area of that? Okay, well, it's a rectangle, so don't make it harder than it is. And let's stick with our color scheme here. We have 3 hours multiplied by 60 miles per hour. And I know you're rolling your eyes saying, you just did that problem. I hear ya. Here's the point. If I find the area, follow me closely. If I find the area under a graph that represents velocity, I will have found the distance that I traveled. A man walks up to you and hands you this graph and says, this represents my velocity, and this is my time. And we're going to assume that velocity and time are in the same units of time, like miles per minute, that would be minutes, okay? And here's his graph. And he said, how far did I travel? Here's how you find it. You find that area. It works. We did an oversimplified example with a rectangle, but we're about to expound on that here. Now, if you're thinking, okay, I can find the area of a rectangle easily, I got you. You can actually find that area pretty easily too. That is, looks like upside down absolute value. You could be like, oh, trapezoid. You could do other things too. You could be like, oh goodness, here we go. Rectangle, and then another little shape, maybe a trapezoid there, and then a triangle there. Lots of cool stuff. But here, like, what about that? That's where the calculus kicks in. Just saying. All right, that just kind of got you started in the right direction. We will proceed in the next video.